loss and metric. This tool will help you understand the concept of loss and metrics. In machine learning, we train models to make predictions based on data. To assess their performance, we need a way to measure how well the models are doing. That's where loss and metrics come into the picture. Loss is a measurement of how incorrect the model's predictions are compared to the actual answers, and the goal is to minimize it. Metrics, on the other hand, give us an overall measure of the model's performance. By optimizing both loss and metrics, we can train models that make accurate predictions and decisions in artificial intelligence and machine learning. This tool will help you understand how loss and metrics work. Let's explore it. Let's say we have X and Y data, as shown here. Based on linear regression analysis, let's say that this data can be represented by this linear equation. Y prime equals 1 plus 2x, and the predicted variable values are shown here. Here are the y values, which are the true output values, as opposed to the predicted output y prime. Mean square error, or MSE, and mean absolute error, MAE, are examples of loss functions. On the other hand, cosine proximity and cosine distance are examples of metrics. Now, if we change these y values, these loss and metric values will be updated as expected. Let's try it. So if we change one of the y values, we see that these calculated values are changed. However, for the sake of simplicity and to focus on the loss and metric, we are not refitting the regression line, and thus the y prime values stay the same. Next is a plot of the data as a scatter plot and the regression line to give a visual of the loss function in terms of how close or far the real data is to the fitted line. Let's discuss how these four values are calculated. Mean square error measures the average of a squared differences between predicted and actual values. Mean absolute error measures the average of the absolute differences between predicted and actual values. Cosine proximity quantifies the similarity between two vectors by calculating the cosine of the angle between them. In machine learning, it's commonly used to measure how close two samples or feature vectors are to each other. Cosine distance is the complement of cosine similarity and measures the dissimilarity between two vectors. I hope using this tool will help you understand the concepts of loss and metrics. Please feel free to modify the provided example data or use your own and explore the various aspects of loss and metric.